Hello everyone. Today we are going to discuss a very important branch of mathematics that is called matrix. Actually, matrix is a very important branch of mathematics. Nowadays, it is used in many areas, for example, engineering, in scientific research also. So, before discussing this topic, let us see what is matrix. To answer this question, I want to say that matrix is nothing but it's an arrangement of numbers, or in this particular context, you can say functions in a rectangular way. What is the rectangular way? Before that, let us write the definition of a matrix. Matrix is an array of. Here the meaning of array is, you can take arrangement of numbers or functions in rectangular way, that is using rows and columns. This is the one definition of a matrix. There are many. So for the example, in our daily life situation, we have seen the timetable. In school, we use timetable. That is also example of matrix. How it is? Suppose that in this days and period, days is Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. These are 7 days. And let us have a period. First period, then second period, third period, fourth period, and fifth period. So, using this information, this is also example of matrix. I have given only 5 periods, but in most schools 8 or 9 periods are there. So this is the example of matrix. Why? I have used rows, first row, second row, third row, and similarly seventh row. And these are the column, first column, second column, third column, and so on, fifth column. So using rows and columns, we have to suppose this first period is taken by some teacher AS, this second period is taken by some teacher RP, and like that. So we write this, and these entries are called elements of the matrix or entries of the matrix. We can write it in this way. Our matrix is this one from here to here. This is our matrix. To write this, we write in this way. Entry, if I suppose it is A, so address of this entry will be A11. First one will show you entry, address of each element will be given by this, where I is number of rowth number, and J is column number. So this is first row and first column element. Similarly, this one is A12, A13, A14, A15. This one is the second row. In second row, this is the first element which is in a first column. So A21, second row, first column. A22, A23, A24, A25. Similarly, we can write others also. Now, let us go to the representation of matrix. How we represent matrix. Here is representation of matrix. We represent any matrix by a capital letter or capital alphabets of English. So, matrix are shown by A, B, C or X, Y, Z, etc. These are represented A equals to in this type of bracket. We can represent this type bracket also or this type. There are three ways to represent a matrix. Here I will mention the general element Aij. Here also you can mention. Here also you can mention. And with this we have to mention how many rows and how many columns are there in a given matrix, and that will be represented by M cross N, or this is called M by N. M by N or M by N. Here M will represent number of rows in the given matrix and N will represent number of columns in given matrix. So order of matrix is nothing but M by N. It is the order of matrix. Here this one is number of rows and this one is number of columns. And this element Aij is the element in for ith row and jth column. This is the representation of matrix. Let us have some examples of matrix. Matrix 0, 1, it is one matrix. 1, 2, 3, 4, it is another matrix. 1, 2, minus 1, it is another matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, it is another matrix. 0, 0, 0, 0, it is another matrix. Minus 1, 2, minus 1, it is another matrix. Okay, now let us write the order of the matrix. In order of the matrix, we must mention first row. How many rows are there? 1. How many columns are there? 2. So 1 by 2. How many rows? 2. How many columns? 2. This one, how many rows? 1, 2, 3. So how many columns? 1. This one, 3 rows, 3 columns. 2 rows, 2 columns. 1 row, 3 columns. Like that. In general way, we can show a matrix this Aij, A11, A12, A13, like that, A1n, because I have taken the matrix of order m cross n. Now this one A21, A22, A23 and so on A2n. Similarly here matrix has m rows, so I will put here AM1, AM2, AM3 and so on AMN. The order of the matrix is m cross n. Now let us go to the types of the matrix. Okay, in types of matrix we will discuss here row matrix, column matrix, square matrix, diagonal matrix, scalar matrix and etc. So first let us discuss row matrix. Any matrix or a matrix which has order 1 cross n, that is only one row, is called row matrix. For example, 1 2 3 is a row matrix. For example, 0 0 is a row matrix. For example, 1 2 is a row matrix. Similarly, column matrix, a matrix which has order m cross 1, that is only one column. So any matrix which has only one column is called column matrix. Example 1 2 3, -1 -2, 0 etc. 0 -1 1/2 etc. As you know that order of these are 3/1, 2/1, 1/1, 3/1. Similarly here also 1/3, 1/2, 1/2, like that. Okay, let us have some other type of matrix, that is null or zero matrix. It is also very simple and but of very use, that any matrix whose all elements are zero or zero is called null matrix. And it is shown as by 0 m cross n, where m cross n is order of that matrix, or we can simply in a bold, we can simply show it by 0. For example, it is null matrix 0 0 0 0 0 0 0 0 0 0 0 0 0 0. So as we know that order we can write, so this is called null matrix. Let us go. Okay, let us have another type of matrix, that is called square matrix. It is also of very importance in this branch of mathematics, because in further chapters when we will discuss determinants, that is based on this matrix. So square matrix, as by the name of its type, it indicates that something length and breadth both are equal. So in case of rectangular, means here we will take number of rows and number of columns equal, then that matrix will be known as the square matrix. So any matrix whose number of rows is equal to number of columns is called square matrix. So here the importance is the for example, if A is Aij, to be square matrix, so it must be M equals to N. For example, 1, this is also a square matrix. 2 0 0 2, it is also a square matrix of order 2. 1 2 3 4 5 6 7 8 9, it is also a square matrix of order 3, and so on. Okay, now let us move to the another type of matrix. Okay, let us understand this diagonal matrix. Before discussing this matrix, we must know what is the meaning of diagonal here. Any matrix is represented by, suppose this way, A11, A12, A13, and this matrix is always taken in a square matrix. So its definition is start from the square matrix. Any square matrix is diagonal matrix if we must remember this, if all the elements except diagonal elements, diagonal, or this is also main diagonal or leading diagonal. Diagonal, if simply it is called say diagonal, we will think about the main diagonal, or it is leading diagonal, are 0. Before this, we must know what is the leading diagonal. Suppose in the case of any square matrix, I am taking this 3 by 3, A11, A12, A13, A21, A22, A23, A31, A32, and A33. Here the diagonal means that actually two diagonals exist here. One is this, and another is this. But we concern only this. This is called main diagonal or leading diagonal. Main diagonal, or it is also called leading diagonal. Okay, when only diagonal is mentioned, that meaning is leading diagonal or main diagonal. Now, so what are the examples of this? Any square matrix is diagonal matrix if all the elements except diagonal, means first it must be square matrix. So 1 2 3 4, it is a square matrix, but the main diagonal are this. Okay, these are not 0, and these we must make 0. So this is the example of diagonal matrix. I can also have 1 2 3 and make it 0 0, 2, make it 0, make it -1, 0 0 0 2. What is the order? 3 cross 3, 2 by 2. So these examples are of the diagonal matrix, in which the elements at the main diagonal or leading diagonals are not 0. Other elements at 0. We can define it in this way also. There is another way to define it. If A equals to, I take it Aij n cross m, because it is square matrix, equals to Aij not equals to 0 if I equals to j. I equals to j are these elements a11, a22, a33, and it is 0 if I not equals to j. In this way also we can define diagonal matrix. Okay, let us move to the another type of matrix. Any diagonal matrix so to be scalar, it must be diagonal. We are starting from the diagonal. To be diagonal, it must be square matrix. So any diagonal matrix whose all elements at main diagonal are equal, it is called scalar matrix. Let us define in that way. Aij, first it must be what? Square matrix. Then k I have taken any constant if I equals to j, means diagonal elements, and other elements if I not equals to j. For example, you can have 1 0 0 1, or you can have -2 0 0 0 -2 0 0 0 -2. So these are some examples of scalar matrix. Now let us go for the another type of matrix. Okay, identity matrix. It is also of importance in this branch of mathematics. Identity, as it indicates, some elements will be identity. So it will start from the scalar matrix. So any scalar matrix So I have taken a scalar matrix. It means it is diagonal matrix. It means it is square matrix. And in case of a scalar matrix, all the elements at main diagonal are same. Any scalar matrix, if all elements at main diagonal is 1, already they are same, but here I have taken it must be 1, so it is called identity matrix. And identity matrix is shown by I, and we can mention the order of the matrix here. Suppose it is n order or m order, so I will mention here in. Example, this is also identity matrix 1 0 0 1, also identity matrix 1 1 0 0 0 1 0 0 0 1. This is also identity matrix. In the same way we can define others. Okay, let us go for. Here we will discuss two matrices together: upper triangular matrix and lower triangular matrix. So in upper triangular matrix, any square matrix here, the important condition is that any square matrix, in which all elements below Remember it, if here it is given upper, so I will take below the main diagonal are 0. For example, 1, 2, 3, 0, or we can take 1, 2, minus 1, 2, 3, 4. Here 0, 0, 0. So you see, below the main diagonal all elements are 0. Similarly, we can define any square matrix in which all elements above, if here I have taken lower, so here we will take above the main diagonal are 0. Example, 1, 2, minus 1, here 0, or I am going to take 1, minus 1, 2, 0, 0, 0, 3, 4, 5 we can take, no problem. So here you see that the elements above the main diagonals are 0. Okay, so we can write it here in this way. Okay, let us go for the another okay, now let us go another topic related to the matrices, that is equality of matrices. What is the meaning of equality of matrices? Equal. When will we say that two matrices are equal? So any two matrices are equal if they satisfy two conditions. If they satisfy two conditions. What are those conditions? First one is they must have same order. That means they must have same number of rows and same number of columns. Second, the corresponding elements must be same. Okay, let us try to understand this with the help of example. Let two matrices A, x, y, 1, 2, which is of order 2, another matrix B, -3, 2, 1, 2, which is order same order. So if they are equal, if A equals to B, when two matrices are equal, we will write A equals to B. So if they are equal, so their order must be same. Here their order is same, and their corresponding elements means x must be equal to x, this y must be equal to 2, and this 1 is equal to this, and this 2 is equal. So we can compare it. xy 1 2 equals to -3 2 1 2. Both are equal, so we can compare x equals to -3 and y equals to 2. Corresponding means here at the same address. The a11 is here x, a11 is here minus 3, a12 is here y, a12 is here 2, a21 is here 1, here is also a21 is 1, a22 is 2, a22 is 2. So these are some topics related to the introduction of the matrices. Remaining topics, for example, the operations of matrices and other related topics, we will discuss in our next video, which will be added in the playlist. Thank you.